This is Henry King. I own Hulk Automotive in Austin, Texas, where I've worked on thousands of cars and trucks since I opened the shop in 2000. I recently had a customer with a nice four-wheel drive Jeep come into the shop. He was going on a hunting trip the next day and wanted 4 floodlights mounted on the roof. He needed everything installed and wired up so he could meet his buddies at the deer lease before sunrise. Each of the lights he wanted installed was rated at 50 watts, and the maximum system voltage was 14.5 volts with the key on, engine running. We need to know how many amps flow through the circuit so we can select the appropriate fuse. If I put in too small of a fuse, then normal system operation would blow the fuse and the customer will be in the dark. If we choose a fuse that is too large, the system won't be able to protect itself and our work could cause a fire. So let's turn this into a word problem to work it out. What amperage fuse do you need to protect a circuit that feeds 4 roof-mounted floodlights, each rated at 50 watts, with a maximum system voltage of 14.5 volts, key on, engine running? The first step in any word problem is always to figure out what you know and what you need to know. In this problem, we see that the voltage is given. It's 14.5 volts. We also know that we have 4 floodlights and each floodlight consumes 50 watts. So let's go ahead and calculate 4 times 50 and we have 200 watts. What we need to find out first is the total amperage. Once we know the amperage, we can then figure out the right size fuse. Next, we need a formula that describes the relationship between voltage, watts, and amperage, which is the formula for Watt's law. You typically see Watt's law in textbooks written like this, where you would put your finger over the unknown variable to figure out your calculation. But I like to say that figuring out Watt's law is as easy as pi, where P equals I times E. Remember that P stands for power, which is expressed in watts. I stands for intensity, or current, which is amperage, and E stands for electromotive force, which is expressed in volts. So, P equals I times E becomes watts equals amperage times volts. Now that we have our formula, let's go back to what we know and what we need to know. We know we have 200 watts. We don't know our amperage, so we'll just write that as A. And we have 14.5 volts, so we substitute that in for V. Now we need to rearrange the equation to solve for the unknown, which means that we need to get the A on one side of the equal sign. So we divide both sides by 14.5 volts. Now we have 200 over 14.5, so I type 200 divided by 14.5 into my calculator and get 13.8 amps. The total current flow in the system is 13.8 amps in this circuit. We have one last calculation to select the proper fuse. A system needs to be able to handle a bit more current than the system draws normally. 135% of normal system draw is a good rule of thumb. So we take 135%. Remember from math class that the word of in a word problem means that you have to multiply. 13.8 amps. To do that math, we need to convert the 135% to a decimal, right? 135% in decimal form is 1.35. 1.35 times 13.8 equals 18.8 amps. So we choose the next closest fuse with a higher rating, which is a nice yellow 20 amp fuse. 2.5 hours later, we had the 4 floodlights installed and working, and the customer was on his way. 2 days later, the customer called up to say thanks for the awesome job and for making all of his buddies totally jealous. It looks like we're getting a few new customers installing floodlight kits. Sweet.